everybody, and welcome back. This is Code.org, Computer Science Discoveries. We're talking about Lesson 12, and this is Sprite Movement. So if you remember in Lesson 11, we mastered the draw loop. In Lesson 12, we're going to use that draw loop to make our sprites move across the screen in a very realistic fashion. So our question of the day is, how can we control sprite movement in the game lab? So you're going to learn how to control sprite movement using a construct called the counter pattern, which incrementally changes a sprite's properties. So it's going to be pretty cool today. We've got a video that we're going to watch here in just a moment, and other than that, Lesson 12 is pretty awesome. So let's get started. First thing out of the gate, this pattern is one of the most important ones in all of programming. It's the counter pattern. X gets X plus 1. It is used to increase the value of a variable by 1. You might call it the counter pattern since it can be used to make a variable that counts up. You use this pattern a lot, especially in the draw loop. Let's see what it looks like. Do this. This program creates a variable counter and then uses the counter pattern to make it count up. When you run the program, what do you think you're going to see on the screen? So we've got to read the program to make a prediction about what the output will be. We have to run the program to check the prediction, and then we have to discuss. All right, so before that button turns orange, you have to type something in the prediction box. I've already typed mine, and it does not let me delete it, so I'm hiding it from you right now. So let's take a look and see what's going on in this workspace. So we've got a variable named counter. It gets 0. Then in the function draw, we've got a background white, text size counter, text counter 0 to 400, and counter gets counter plus 1. So it looks like a variable labeled counter is going to increase in value. That's I think my prediction. Let's see what I wrote. And remember, I could be right or wrong. This is all about just predicting. I said in the bottom left, words will show up and count up by 1. So that was my original prediction. You guys make your prediction. If you need to pause me, go ahead and do that. Otherwise, when you are ready, hit that run button. And remember, once you hit run, you can't go back and edit your text. So it doesn't matter if you're right or wrong. It's just a prediction. So let's see what happens. Oh man, how cool is that? So the counter in the bottom right corner, bottom left corner, counts up, but it also increases in size over and over. Wow, how amazing is that? All right, let's hit finish and continue. This is going to be a great level. Great lesson, lesson 12. And it's time for a video.
You can animate with sprites too. To do this, you'll need to update their properties inside the draw loop using the counter pattern. For example, this program creates a sprite called MySprite. Then, inside the draw loop, it uses the counter pattern to increase the sprite's X position by 1 in each frame. This makes the sprite move smoothly across the screen. Adding a second sprite to a program is easy. You just use the create sprite command again. This program animates 2 sprites called Sprite 1 and Sprite 2. Sprite 1 uses the counter pattern to move across the screen by adding 1 to its X property. Sprite 2 moves down by adding 1 to the Y property on each tick of the draw loop. These sprites have lots of other properties, but our program only needs to deal with the ones that are changing. Sprites already help you write more readable programs, and they are going to be extremely helpful and powerful tools for making fun games and animations. So stay tuned.
All right, short, sweet, and to the point. Let's continue. Level 4, using the counter pattern, you can write programs that animate sprites smoothly. Adding to or removing from a sprite's X or Y property in the draw loop makes your sprite move just a bit each time it's redrawn. do this. Read the code that makes the jet go up the screen. Add code that makes the plane move to the right as in the image. Okay, so we're trying to duplicate this image over here. So I'm going to hit run to see what I've got. All right, so I've got the jet moving up. I've got the plane is stationary, so I have to make the plane move. So let me take a look at my workspace and see what they've given me. I've got a variable jet. Jet is set to the jet picture. We've got a variable plane. Plane label is set to the picture of the plane. Line 6 starts my function draw loop. 7 is the background. Super important so that I don't see all of the images before that. 8, it says move the jet up. So we've got jet equals jet.y minus 3. So minus 3 because remember our y-axis decreases in value as we move up the screen, not down, not like math class. So now in line 10 it says move the plane over, add your code here. All right, so I've got to do the same thing for the plane that I did for the jet, except for one big difference. Instead of y, I'm going to change the x value. So I'm going to start here. I'm going to get a sprite.x. I'm going to drag it over. And notice, see, when it's here, it's just that red block. But once I get over here, it actually adds that additional block that I need, the gets value. So Sprite, not Sprite, it's called plane. So plane.x gets, well, I need to increase in value from left to right. So I need an addition equation, so plus equation. And then I'm going to get another sprite.x, drag it over. So I need plane.x to get plane, not that kind of plane, the wrong plane. Plane.x plus, well, if that's minus 3, I'm going to say plus 3 here. All right, and that should be all I need to do. So let's see what happens. All right, so my plane is flying, my jet is flying, and life is good. My sprite movement mirrors that in my example photo. So remember, plane.x gets plane.x plus 3. That equal sign is not an equal sign. We say the word gets the value of, or gets. Hit finish. Let's move on. All right, level 5. If adding a sprite's x coordinate makes it move to the right, how could you make it move to the left? This program make your program animate like the image to the right. Update fly.x inside the draw loop so that in each frame the fly is drawn a bit further to the left. Tip, you can make your sprites move faster by adding or subtracting larger numbers. The fly in your example moves about twice as fast as the plane in the last level. All right, so if the plane moved 3, then this fly is probably moving 6. So let's see what I got. Stationary fly. So line 1 is variable fly. Line 2, they assign the fly to the picture fly. Line 4 starts the draw loop. 5 is the background. Now I need to get those movement blocks. So remember, I start with the sprite drawer here. So if the sprite is moving to the left, the value that's going to be changing is the x value. So I need this sprite.x, drag it over, let go of it. I need to rename it to fly because I don't have any variables named sprite. They're named fly. Now I need a math equation. So if the sprite is moving from the right to the left, that is a decrease in x value. So I need a subtraction block. I'm going to grab another .x, drop it in the front of the equation. Remember to relabel those sprite labels. So it's fly.x gets fly.x minus, and I'm going to say 6 here. Why? Because of this tip. Okay, the tip indicates that it's twice as fast as the plane. The plane was moving 3, so the fly must be moving 6. And that should be it. By the way, this block here is just a spacer. It doesn't do anything to your program. It's just to make it more visually appealing to you, the programmer. Let's hit reset and run. There he goes. Fly, fly. Fly, little fly. Shoo fly. Don't bother me. And that's it. Da-da-da. Level 6. All right, so we're going to use both the X or Y properties of a sprite to make it move diagonally. You can use the watchers under the code area to see how each property is changing. Do this. Read the code that makes the mouse go down, run the program, and look at the watchers to see what is happening to the mouse.x and the mouse.y properties. Add one more line of code that makes the mouse move diagonally. Run the code again and look at the watchers. And then we have a challenge to use the sprite's rotation property so that it faces the direction it's moving. All right, so what the heck am I talking about here? Well, let me move this up so you can see a little bit better. So I've got my workspace and my toolbox. You've used that for a long time. Now I'm starting to get into programming that requires me to look at either the console log or the watchers over here. Watchers is over here, and that's what they're talking about. So when I hit run, I want you to watch this side of the screen right here, the bottom right corner of the screen. I'm going to hit run. Let's see what happens. Oh, so it's actually telling us what the Y value is of the mouse as he moves down the screen. And the mouse X value stays at 50 and it doesn't make any kind of changes. So then that helps me understand what the world's going on over here. So I've got a variable mouse assigned to mouse. They've scaled it down to half the size of the picture, the original picture. Line 5 is my draw loop, 6 is my background, 7 is my mouse.y value. It's the counter for the Y. So now I need to add a counter for the X. So I'm going to grab the sprite.x. Don't forget to change it to mouse. And I'm going to do, okay, so if it's Y, he's at the top, he's moving down. Okay, X, he's moving to the right, so I'm going to get a plus sign, plus equation. Then I need another mouse.x. Drag it to the front of the equation, change the label to mouse, and then I'm going to say plus 2. Whoops, I messed that up. Mouse is a plus 2. All right, I'm going to run this to see what I've got first. Okay, so he is moving diagonally across the screen the way he's supposed to, and I'm going to run it one more time. This time I want you to look over here at the watchers and see what's happening. All right, so you should notice that my X and Y values are increasing in sync as the mouse moves diagonally across the screen. Okay, so if you want the mouse to face the direction that he's moving, you have a mouse.rotation. So I add the mouse.rotation, and if he's looking down, I'm going to say 75. I don't know if this is right or wrong. I'm going to test it out. So mouse.rotation 75. And let's see. Whoops, wrong way. So let's say negative 75. Negative 75. Whoops, a little too much. But I'm in the right direction, so negative 60. All right, getting better. Negative 50, maybe 40. Negative 40. There we go. So mouse.rotation, I ended up with negative 40. You could have something close to that. And hopefully you saw I didn't have the right answer. I just played around with it until I figured it out. And that's okay. All right, let's hit finish and continue. Da-da-da. Level 7, we have to read the program and predict which of the following animations will be produced. Well, on this one, as with other predictions, once I've hit a button, it's not going to let me change. So let's take a look at the code first. We've got a red car, yellow car, blue car, green car. Scroll down to the function draw loop. So we've got red car first, +4, yellow car second, blue car third, Y car or green car fourth. So remember, whatever's drawn first is going to be in the back, and whatever is drawn last is going to be on top. So I think what was going to happen here is the blue car is going to overlap the red car, and the yellow or the green car is going to overlap the green. What did I just say there? I think the green car is going to overlap the yellow car. So let's see what I really did predict. Looking at my choices here, I ended up choosing C. Green overlap. Oh, I was completely wrong. So green doesn't overlap yellow. Green overlaps. Ends up looking like blue, right? Yellow goes underneath. Huh, interesting. So hit run, see what happens. Was I right? Looks like I was right. I was right when I did this the first time. I was wrong this time, and there's nothing wrong with that. It's okay to be wrong. All right, from here on, I'm going to hit finish. Move on. We are on the practice level. So remember, practice level, choose one. If you do more than one, that is amazeballs. You don't have to, but if you do, I'll give you a bonus for it. So let's take a look at this spinning frying pan. The spinning frying pan. All right, so use the counter pattern on a sprite's rotation property can make it spin around. Use the counter pattern with the pan sprite's rotation property to make it spin as in the image to the right. So let's see what I got. I got a pan and nothing else. All right, so sprite.rotation, drag that over. Sprite, and it's not Sprite, it's called pan. Pan.rotation gets, and we got some math here. So it's going to be a plus. It's going to get a pan.rotation plus, what, 1? Maybe. Pan.rotation plus 1. See if plus 1 works. Yeah, plus 1 looks like it's about right. Maybe not. Maybe it's a 2. Two looks a little better. And that's it. Pan.rotation gets pan.rotation plus 2. Line 6. Finish. Continue. One more time. Do the other two if you'd like some bonus. Otherwise, hit that finish button. Bonus adds up, actually. You know, when you do a little here and a little there, pretty soon it helps you out when you screw up on an assessment level. All right, so in this one, we use the counter pattern to make all 3 fish move in as the image to the right. The blue fish should move faster. Green fish should move slower. All right, so just like the image over here to the right, let me decrease this down a little bit. Blue fish should go faster. So that means his number in his counter pattern should be higher, and the green fish should be lower. So honestly, this is an assessment level, so I'm not going to do it for you, but I say you probably should set your blue fish to counter pattern plus, or no, actually it'd be minus because you're moving to the left. Minus X, I would do a minus 3. For green, I'd do a minus 1, and for red, I'd do a minus 2. Okay, so what you're going to be working on is down here. You see where they've got orange fish, line 13? You're going to replicate that for green and for blue. Green and for blue. All right, good luck on that assessment level. And then last but not least, you've got your challenge level. Once again, choose either one, more fish or bubbles. These are actually kind of cool, so have fun with that. And that's it for lesson 12, Sprite movement. See you later.